Usually when we talk about a major cybersecurity incident, there's this expectation of a high-tech heist.
Right, like a cinematic break-in?
Exactly.
Yeah.
We picture a team of hackers rappelling down an elevator shaft or, drilling into a digital vault and bypassing laser grids.
Yeah, it's that classic Hollywood mentality. I mean, we just assume that if a major tech company gets compromised, it took an army of criminal masterminds,
Right.
people writing zero-day exploits specifically targeted at that company's core infrastructure.
But then you look at the reality of modern cloud architecture, and, well, that impenetrable vault looks a lot different.
He really does.
It's more like you built the most secure bank in the world, the walls are 10 feet thick, the time locks are perfect, but you left the back door propped open for the guy who refills the vending machines in the break room.
That is essentially exactly what happened in the recent Quicknode incident.
Okay. Yeah, and that's what we are getting into on today's deep dive. We're looking at a stack of sources today, mostly the official Quicknote security notice PDFs and some accompanying technical analysis chat logs.
Which really break down the whole breach in detail.
They do. And our mission today is to unpack exactly what happened during this critical 13-minute window where a backdoor was left wide open.
We're also going to explore the hidden dangers of what we call zombie data.
Right. The stuff left in old, unused accounts.
Yeah.
And most importantly, we want to provide you with a concrete playbook for how you can protect yourself.
Because it's a very real threat.
It is. And I'm just so fascinated by this specific breach. The irony is just, Quicknote is a cutting-edge blockchain infrastructure company.
Yeah, processing billions of requests, handling decentralized nodes.
Exactly. But they were compromised not through some complex crypto heist, but through a totally mundane business intelligence tool.
It's a textbook case study in third-party supply chain vulnerabilities. The attackers didn't go anywhere near their proprietary code.
They didn't even touch the blockchain.
No, they came through a third-party analytics platform called Metabase Cloud.
So let's get into the mechanics of that breach, because the timeline here is, frankly, it's terrifying.
It happened fast.
Yeah, July 30th, 2026. The vulnerability was inside Metabase Cloud, which, like you said, Quicknode uses to crunch numbers on user dashboards.
Right.
And looking at the logs, the specific CV tags are CVE 2026-33725 and CVE 2026-59827.
Which are remote code execution or RCE vulnerabilities.
And I'm kind of stuck on this RCE concept in the specific context.
How so?
Well, Quicknode is a blockchain company, right? So if their blockchain wasn't touched, why did an analytics tool, essentially just a dashboard for looking at charts, why did it have a backdoor to user data? Like, why does it have the authority to execute system-level code on a server in the first place?
To understand that, we have to look at the specific endpoint the attackers exploited. It was the API endpoint for serialization import.
Okay, serialization.
Yeah, the key word there is serialization. When you want to move complex data structures between servers, you can't just send them as, like, a raw 3D object in memory.
Right.
You have to serialize them. Essentially, you break them down into a flat string of text or code, send that string across the network, and then the receiving server deserializes it.
Got it. So it reassembles it back into the original complex object.
Exactly.
It's kind of like they packed a bomb in a flat pack IKEA box, right?
That's a great way to put it, yeah.
And when the Metabase server opened the box and dutifully followed the assembly instructions, it just inadvertently built and triggered the bomb.
That captures the mechanism perfectly. I mean, the Metabase import endpoint was designed to accept serialized data for legitimate analytics.
But it just assumed whatever was in the box was safe.
Right. The deserialization process lacked proper sanitization. It didn't strictly limit what kind of objects could be built. So the attackers sent a malicious payload disguised as import data. When the server reassembled it, those instructions tricked the underlying Java environment into executing arbitrary system commands.
So suddenly they have a remote shell.
Yeah, they can query the database, export records, or just run any script that the Metabase application has permissions to run.
And the window for this exploit, this is the crazy part, it was incredibly brief.
Very brief.
Just 13 minutes. Between 03.21 and 03.34 UTC.
Yeah.
I mean, that's a digital smash and grab.
Mm-hmm.
They threw a brick through the window, grabbed what was on the display counter, and peeled out before the alarm even finished ringing.
And 13 minutes is practically an eternity for a script.
Wait, really?
Oh, yeah. The speed of that exfiltration just highlights how automated these attacks are. Attackers are constantly scanning the entire internet for servers running vulnerable versions of software.
Right. They're not manually typing this out.
Exactly. The moment a proof of concept for an RCE drops, the scripts are already written to exploit it, dump the databases, and move on.
Man. So Metabase patched the issue eventually, right?
Yes, they patched it across their cloud instances, revoked the compromised access, and officially notified Quicknode a week later on August 6th.
And Quicknode subsequently rotated all their credentials for their Metabase integrations.
Yeah.
Okay, so they get in. And since Quicknode is a blockchain infrastructure company, my first thought as a user is just immediate panic.
Natural.
You think, wallets are drained, private keys are stolen. But looking through the official security notice, that actually didn't happen.
No, it didn't. The architectural separation is really what saved them there. The actual blockchain infrastructure was entirely unaffected.
Which is a huge sigh of relief.
Yeah, the attackers did not get transaction data, no wallet information, no private keys, passwords, or financial information.
So no funds were affected at all.
Zero funds were compromised. The Metabase integration simply did not have access to the production databases where those critical secrets are stored.
Okay, that's the good news. But since the attackers were only inside a third-party BI tool for 13 minutes, what exactly were they able to grab?
Because Metabase was tracking dashboard usage, they managed to scrape full names, email addresses, Telegram usernames if they were provided, and the IP addresses recorded when users signed into the Quicknode dashboard.
And here's the part that genuinely frustrated me when I was reviewing the sources.
Yeah.
The irony of these old records. Like, I might have spun up a Quicknode dashboard 3 years ago just to test a smart contract for an afternoon.
Sure, just messing around.
Exactly.
Mm.
And I haven't logged in since. Are you saying my old IP address and Telegram handle were still sitting there during that 13-minute smash and grab?
Yes. That's the core of the issue. The underlying problem here is the standard operating procedure for cloud infrastructure providers.
Which is to just keep everything.
Pretty much. They routinely keep historical analytics data indefinitely, unless you explicitly ask them to delete it.
Why, though?
Well, operational databases, the servers handling your active logins and transactions, those are usually kept lean so they run fast.
Right, for performance.
But the analytics data gets piped into separate data warehouses like Metabase. Storage is incredibly cheap now.
So they just hoard it.
Yeah. Companies operate on the assumption that their data science teams might eventually want to analyze long-term trends. You know, like user churn over a 5-year period.
It's like a gym keeping a logbook of every single time you swiped your membership card 5 years ago, just in case they want to analyze foot traffic today.
That's a great analogy.
And then someone steals that logbook. I mean, you canceled your membership ages ago, but suddenly someone breaks into the back office, steals that dusty old logbook, and now a criminal knows exactly what time you used to show up on Tuesdays.
Right, and to take that gym analogy even further, it's not just that they have the logbook.
What is it?
It's that you have absolutely no visibility into the fact that the logbook even exists.
Oh, wow. Yeah.
In the security community, we call this zombie data.
Zombie data.
Yeah, it's information belonging to an account that is functionally dead to you. You uninstalled the app, you forgot the password, you haven't thought about the service in years.
But the data is still alive.
Very much alive, just sitting on a server somewhere entirely unmonitored by you, waiting to be caught up in a third-party breach.
Okay, I get that it's creepy they have an old IP address and my email, but if my passwords and my private keys are safe, aren't I fundamentally safe?
You're safe from a direct brute force hack of your Quicknode account, yes.
Right. So what is the actual danger of losing this zombie data?
Well, it all comes down to how attackers weaponize it. Modern attackers rarely rely on brute force when they can use psychological manipulation.
Okay, so phishing on steroids, basically.
Exactly. This leak provides what we call enrichment data for scammers. They now have a highly specific profile on you.
Name, email, Telegram handle, IP address.
And confirmation that you are a Quicknode or crypto user.
Ah.
They combine these disparate data points to craft highly targeted spear phishing campaigns.
Right, because if I just get a generic email saying, "Dear user, your crypto wallet is locked," I know it's a scam.
Your threat detection fires immediately.
But this enrichment data, it's like a con artist who knows your dog's name and your favorite coffee shop before they even approach you.
That's it exactly. It's designed to bypass your natural skepticism by building a false sense of trust.
So what should we expect to see?
Based on the chat logs analyzing this breach, you should expect highly convincing emails designed to look exactly like official Quicknode communications.
Okay.
You'll likely see Telegram direct messages from accounts pretending to be Quicknode support.
Using the exact handle you provided, of course.
Right. They might send fake airdrop announcements or urgent alerts claiming a security upgrade is required for your nodes.
And they might even use your leaked IP address to pretend they know your physical location. Case it.
Yes, to intimidate you. They'll say something like, "We detected an anomalous login from your IP address in Chicago."
That is so manipulative. But Quicknode has an official stance on this, which is crucial.
Yes, they do.
They state very clearly that they will never, under any circumstances, ask for your password, your seed phrase, your private keys, or your credentials.
Never. That is a hard boundary. Legitimate infrastructure companies simply do not need your private keys to troubleshoot a node.
Right, so if anyone asks for that information, regardless of how much enrichment data they throw at you to prove they are legit, they are hostile.
100%.
Okay, knowing that attackers have the perfect bait, how can we actively verify what's real and harden our defenses?
We need a defensive playbook.
Let's start with email. If I get an email from Quicknode tomorrow, what is the 30-second check I could do to see if it's real?
You have to look at the email headers. The display name, the part that just says Quicknode support, that can be forged by anyone in about 2 seconds.
Right, you can just type whatever name you want.
Exactly. So you need to open the original email on a desktop client, click the options menu, and select Show Original or View Headers.
Okay, and I know those headers usually look like a massive wall of code. What specifically am I hunting for?
You're looking for the authentication results. Specifically, 3 cryptographic protocols: SPF, DKIM, and DMARC.
And what do I want to see next to them?
Next to each of those acronyms, you need to see the word pass.
Okay, let's break down those acronyms briefly, just so we understand why a pass actually matters.
Sure. Let's take DKIM first, which stands for Domain Keys Identified Mail.
It's kind of like a digital wax seal on an envelope, right?
Yeah, that's a perfect visual. The sender server attaches a cryptographic signature to the email body. Your receiving server checks that signature against a public key.
So if the email is tampered with in transit, the seal breaks.
Exactly. The signature breaks and DKIM fails.
SPF.
Sender Policy Framework. Think of it as a guest list at the door of a club.
Okay.
Quicknode publishes a public list of all the IP addresses authorized to send emails for them. When an email arrives, your server checks the sender's IP against that guest list.
If it's not on the list, SPF fails.
Right. And DMARC is just the overarching policy that tells your email provider what to do if SPF or DKIM fail.
Usually to throw it in the spam folder.
Yes.
And the return path needs to be strictly quicknode.com.
Yeah.
Right?
Absolutely.
Okay, so if the headers pass, is it completely safe?
It guarantees the origin, but regarding safe communication, the safest protocol is still to never click links in unexpected emails.
Even if the headers pass?
Even then, if you get a notice and you are unsure, manually type the official email address into a new draft. For this incident, it's eventresponse@quicknode.com.
And just ask them to confirm the notice ID.
Right. Force them to verify the issue on a fresh thread that you initiated.
Okay, what about Telegram? Since they grabbed handles, I imagine DMs are going to be a mess.
Telegram requires immediate hardening. Go to Settings, then Privacy and Security, and turn on 2-step verification immediately.
And behaviorally.
Establish a zero-tolerance policy. Block and report any Telegram DM claiming to be Quicknode support. They just do not initiate support tickets via random DMs.
Got it. And any message asking you to reset your password, verify your wallet, or providing a URL that isn't exactly quicknode.com is completely fake.
Completely fake.
What about passwords? Do I need to scramble to change my Quicknode password?
No, you don't need to rotate your Quicknode keys or passwords because of this incident. The credentials weren't in that database.
Okay, good.
But you do need to ensure you aren't reusing the affected email's password anywhere else.
Password reuse. The classic downfall.
Yeah, if they have your email and you use the same password everywhere, your risk goes way up.
So we've covered the immediate threats. But if we know this old data is a massive liability, what is the permanent solution for a service we haven't touched in years?
Well, the only foolproof defense for unused services is total deletion.
But wait, usually I just go to a website and click delete account. Why isn't that enough?
Because clicking delete account usually triggers what developers call a soft delete.
A soft delete.
Yeah. It deactivates your front-end login, and it might remove your active profile from the main database, but it rarely propagates downstream to the analytics warehouses.
So your ghost data is just left behind in those third-party BI tools.
Exactly. Those databases are managed by different teams with different retention policies.
Which brings us to the nuke it. strategy.
The nuke it strategy, yeah.
We have to force their compliance team to actually scrub the data. And the sources provide a really specific template for requesting this data deletion.
The wording here is absolutely critical.
Okay, let's walk through it. You open an email to eventresponse@quicknode.com.
Right.
The subject line should be data deletion request, Metabase incident.
Yes.
And in the body, you state that you received the security notice, you haven't used Quicknode in years, and you are requesting confirmation of whether your account was affected.
And then comes the most important part.
Right, the legal trigger.
Yeah.
You must explicitly ask them to permanently delete your account and all associated PII, personally identifiable information.
And you have to include the phrase, including historical analytics data.
Including historical analytics data per their privacy policy.
Yes. That specific phrase is what unlocks the data warehouse. It forces the compliance officer to look beyond the primary operational database and actively purge your records from existence.
Because if you don't say that, they just deactivate your login and close the ticket.
Exactly.
Wow. It really is about taking back control of your digital footprint. I mean, it's tedious, but the alternative is waiting for the next zero-day exploit to realize a company still has your IP address from 5 years ago.
It is tedious, but it's necessary.
Well, we've covered a lot of ground today. We unpacked how a critical 13-minute vulnerability in a third-party BI tool exposed the zombie data of crypto users.
Creating a perfect storm for targeted phishing.
Right. We covered how to verify email headers, secure your Telegram, and formally demand the deletion of your historical data using the nuke it strategy.
And I think there is a broader implication here that everyone really needs to internalize.
What's that?
Every single time you try a new app or sign up for a dashboard or just test a service for an afternoon, you leave a digital ghost in a third-party analytics warehouse.
Just sitting there.
Yeah. How many other zombie records of your IP and contact info are sitting in business intelligence databases right now, long forgotten by you, but just waiting for the next zero-day exploit?
That is a terrifying thought to end on, but a necessary one. Check your old accounts, clean up your footprint, and stay safe out there. We'll catch you on the next deep dive.